So with that, would love to introduce our next speaker. Our next speaker received her PhD in software engineering from UC San Diego. She believes that the true potential for machine learning can be unlocked by collaborating on the data. An engineering leader at our very own Snorkel AI, she focuses on building the core programmatic labeling and iterative model development experience. Prior to joining Snorkel, she managed teams building internal tools for the AI ML organization at Apple and was one of the founding engineers on Google Photos. Please give a warm welcome to Roshni Malani.
Thank you so much for that kind introduction, Arthi. I am incredibly honored and humbled to talk to you today about building AI applications collaboratively. It was one of the fundamental pillars of the data-centric approach that Alex outlined in his keynote. AI applications are built in teams of subject matter experts that have deep understanding of the domain, with data scientists and machine learning engineers who work together to define the what and the how of the application. We want to be able to collect as much signal as possible from every member of the team. And as we've seen throughout the day today, AI applications also have to become more dynamic. Being able to adapt to changing requirements can only be done by collaborating on the same platform. As we've heard all day long today, we've been seeing this shift to focusing on data, and it's leading to more performant AI systems that are more fair, more robust, and more scalable. We've seen evidence that improving your data improves your model. Who knows your data best? The domain experts. We must empower them with multiple ways of sharing their expertise, not just the label itself, but the context or the nuance behind it. By doing so, we can accelerate the development of AI applications. However, today we are often blocked on labeling our data. We work with many customers who cannot crowdsource their data. It requires high expertise, as you've just seen, and also could have privacy concerns. So think medical records or financial records. A common pain point we've heard from our customers is data scientists saying it's hard to get enough time with our subject matter experts. Often, data scientists just get the labels and not the subtlety behind the label. For example, a data point could be labeled A or B, but this specific portion of the document is why it's clearly labeled A and not B. It's hard to give that nuance through just the label itself. Our data scientists also want to know how much confidence, high or low, that the annotators have in labeling that data. Today, the tooling is woefully inadequate. Our high expertise domain experts, like lawyers and doctors, are often busy copy-pasting between cells on spreadsheets that are emailed back and forth. Which spreadsheet has the latest labels from John again? Oh yeah, in that email with the Excel attachment. And has Julie reviewed those labels yet? We need to unblock data. How can data scientists and machine learning engineers work together with subject matter experts to utilize their knowledge most efficiently? How can we collaborate to maximize the value and the velocity of the data labeling process? Well, we can get higher value annotations. We must use domain expert time more effectively than just the tedious hand labeling. We must maximize the transfer of knowledge with higher value labels that provide more context or information about the data. And as a result, we may also get more accurate labels. Not only do we need more value in our labels, we also need it at a higher velocity. We must create interfaces that have less friction than emailing spreadsheets back and forth. The key insight here is that as we shift our focus from iterating on the model or code to iterating on the data, we need to bring the power of modern collaboration tooling. Think Google Docs, think Git, real-time collaboration features with version control for our training set. There's definitely parallels here with Justin's talk about machine programming, with the goals of reducing development time and improving the quality in terms of correctness and performance. You've seen this basic diagram several times today, and I want to bring it up again to show you how our data scientists and our domain experts are operating in silos with no common means or tooling for collaboration. Labeling data has been a manual and tedious process, often very expensive, and it's done by the subject matter expertise. It's only done once because doing it again would be just so much more onerous. Thus, the data scientists are constrained to iterating on the model where marginal improvement has been observed. Let's visualize this hand labeling process a bit more concretely. To really illustrate the point, imagine each dot here represents a data point that is available. For simplicity, you would split into a training and a validation set. The validation set would be hand labeled. And also, the training set would need as many data points as possible to also be painstakingly labeled manually by hand. As you can see, manual labels, as Chris mentioned earlier today, tend to be slow, expensive, and static. We're not going to do this again. In a data-centric world, we can maximize collaboration by creating another iteration loop focused primarily on the data. We can do this by creating multiple ways to capture expertise in the same platform. Snorkel Flow introduces a new way to capture expertise called programmatic labeling, which you've heard quite a bit about earlier today. This accelerates AI development. It's based on weak supervision techniques pioneered by our founders during their time at the Stanford AI lab. The core collaborative loop operates as follows. After labeling some data and training a model, you analyze the performance gaps. You identify these gaps that allow you to create more targeted and relevant labeling assignments, especially for corrective or iterative work. For example, where the model is most wrong, or on specific high-value examples, or on commonly confused classes. This is an active learning approach with a human in the loop. The second step is to iterate on these gaps collaboratively by gathering all the information you can to label even more data, with which you can again train a model and analyze it. You repeat the same iterative loop after deploying your model and monitoring a slice of production data. As a result of this collaborative loop focused on data, an order of magnitude improvement is observed in your AI application. You've been hearing about programmatic labeling throughout the day, but let's quickly visualize how it works in action. With programmatic labeling, subject matter experts work with the data scientists to encode their domain knowledge as labeling functions, incorporating heuristics, rules, dictionaries, all the sources of information available to help inform what the label for a data point can be. As you can see, programmatic labeling is a more efficient way to label your data. Snorkel Flow doesn't require any ground truths. You can train your model solely based on these programmatic labels, as Chris showed us in his origin story of Snorkel earlier today. You may want to use Snorkel Flow to add a small amount of hand-labeled data. You could use it for validation, and you only need as much as you want to have confidence in your evaluation. You could also hand-label data in your training set. It can guide the model development, such as hyperparameter tuning or model training, or it can help you handle the long tail of data that doesn't generalize easily. Snorkel Flow automatically weighs and denoises these labels, both the ones generated programmatically and those generated by hand, to create high-quality training sets at scale. The main idea is to use as much signal as possible in any form factor that you have available. The current standard and most obvious way of getting subject matter input is ground truths, labels for training and evaluation. But programmatic labeling provides another opportunity to get domain expertise input. This new approach not only allows us to iterate faster, but also gives us more insight into how to improve our end model performance. But let's take a deeper look at how it enables collaboration. In Snorkel Flow, we've built multiple ways to capture domain expertise. We'll do a high-level overview now and explore these features in depth through a case study. We want to maximize the bandwidth of information that subject matter experts can provide. We want to convert their expertise at any level available. Examples include comments, which are free-form context about a data point, which provide the why. Tags may highlight properties about your data points, clustering them in ways that might provide deeper insight into your machine learning problem. Of course, labels can be used as ground truth. Can also write low-code templates to capture patterns in the data to label. And you also have the full ability to use code to encode heuristics and domain knowledge. This diversity of input allows subject matter experts to share rich information about the data with the data scientists, multiplying their value. We also need to create a more integrated platform that reduces the friction and allows for faster iteration. We can get higher velocity when everyone sees a consistent view of their data points in full context. No more passing snapshots back and forth. You can request annotations simply with a shared link. You can get real-time updates of the labeling progress with full support for versioning. When there are difficult splits or portions of the data that data scientists have a hard time labeling programmatically or covering with a model generalization, we can focus our manual efforts with the push of a button. To show, not tell, how Snorkel Flow enables AI teams to collaborate both synchronously and asynchronously to get labels with more value at higher velocity, let's dive deep into a case study. Let's imagine we operate SnarkBank, a fictional bank that provides loans for small to medium-sized businesses. This is a running fictitious example based on lessons learned from our customers. It demonstrates the quality and speed with which you can adapt to changing business requirements, such as label understanding evolving, label schema changing, or data drifting. At SnarkBank, we have highly skilled loan officers who evaluate business loans. They specialize in specific industries, of which there are thousands. As you can imagine, the loan application for a boutique cupcake store is going to be quite different from one for an automobile manufacturer. The goal is to build an AI application to route a new loan application to the appropriate loan officer who specializes in that industry. So let's get started with our classification application. We start with a database of about 500,000 loan applications, none of which are labeled. And we have about 1,000 classes. So first, data scientists and subject matter experts can sit down together to capture expertise as heuristics. The first idea for a labeling function might be that if the exact text of the label is in the loan application, then likely that's the label. Or we could use some keywords from a dictionary or generic ontology to help us programmatic label, or we could use some auto-suggested labeling functions. Doing this, we have generated approximately 300,000 programmatic labels that we can use for training. But how do we evaluate whether these heuristics are any good? Luckily, we had already started the process of collecting some hand-labeled ground truth for evaluation. Notice that we're creating a batch that has about 5,000 data points, which is a tiny, tiny sample of the 500,000 data points available to us, about 1%, because that's all we'll need for validation. Because we want the highest quality labels we can get for our test set, we've asked several loan officers to label the same batch of data points. Now, instead of pinging for progress and being unable to see partial results, our senior loan officers can make sure that our junior officers, who are labeling independently within the platform, are on the right track. We can see overall information such as the total completion rate and the daily annotation rate, and we can also see individual information such as individual annotator completion status, as well as inter-annotator agreements, optionally broken down by per class. Furthermore, we can denote the senior loan officer, Annie in this example, as an expert and see her agreement rate with the junior officers. We can choose which annotators to aggregate before committing the labels to ground truth. Now that you've seen the basic tools for creating batches for annotation, which can be analyzed, aggregated, and committed as ground truth, let's walk through 3 scenarios that demonstrate the dynamic, messy environment in which, as Chris mentioned in his talk earlier, long-lived AI applications tend to be developed, where the iterative loop of improving model performance requires collaboration between the subject matter experts and the data scientists in the same platform. As you will see repeatedly, collaborating on the data will increase the value of our data as well as getting labels with increased velocity. For our first example, let's take a look when the label understanding changes. So let's assume the data scientists have trained a model, looked at the analysis, and are digging into the analysis for each class in particular. It turns out that the annotation instructions either weren't clear or were interpreted differently. So for example, the keyword nursery could be interpreted as a garden supply business or as a childcare center. And so what we want to do here is filter data points about nursery and click to create a batch for annotation. These are our known unknowns that we can iterate on. As you can see, it's increased velocity when all you can do is quickly filter and press one button to create and start off a batch of annotation. After this annotation, we can work together with the data scientists and subject matter experts to either refine existing labeling functions, create new ones, validate the model after we train it with the new hand labels. Another common problem that occurs is that the label schema changes. This includes adding a label, removing a label, splitting a label into multiple labels, or merging labels into one. The example we'll look at here is to split the label restaurant into 2 labels, brick and mortar and food truck. Again, we're going to be rinsing and repeating the process of getting subject matter expertise. We can either refine or add new labeling functions or request targeted hand labeled data to add to our ground truth for validation. Here, when we request annotators to add more ground truth, we can actually request additional tags or properties about the data that we think might inform our labeling functions, such as the price or popular meal times. As you can see here, we've gotten additional rich metadata about businesses to inform our labeling functions. And as a last example, let's take a look at data drift, a situation that's been discussed by Sharon and Andrew earlier today. We've developed our model and identified a particular slice of production data that we want to monitor. Let's say pharmaceutical companies. We notice a drift in label distribution for this particular class. It turns out that lately there have been more loans coming from businesses involved in the vaccine manufacturing industry, as well as industries involved with associated transportation infrastructure. Not only were we able to identify this trend quickly from within the Snorkel Flow platform, but we were also able to address it quickly. As a result of being embedded in the same platform as data scientists, our subject matter experts have gone through the collaborative iterative loop many times by now and are able to identify patterns in the data and encode them using low-code interfaces. Thus, you can see that the quality and speed of data labeling increases over time as you iterate on your AI application collaboratively. Thanks for joining me in our journey operating SnarkBank. In addition to AI application development, we learned that it occurs in dynamic environments. I hope you can relate to some of the examples presented today, such as label understanding changing, label schema evolving, and data drifting. AI application requires iterative improvements, not just to the model, but also to the data. AI applications are built by teams of domain experts and data scientists working together. And we want to empower their activities of collaboration between all of them. We want to create a central hub for all of the rich artifacts that are created during the process of building an AI application. This empowers our users to follow best practices um, that can be supported with best-in-class collaboration tools. The agility to adapt your machine learning model comes when subject matter experts can encapsulate their expertise in multiple ways in an integrated, seamless way. That is, collaborating in the same platform maximizes the value and the velocity of your data-driven AI applications. I want to give a big thank you to Braden Hancock, the visionary behind this work, and the incredible team at Snorkel for bringing it to life. And thank you all for listening. I'm happy to take some questions.
Thank you so much, Roshni. Your talk touched on a bunch of themes that we've heard throughout the day and also made it super concrete in how that works in Snorkel Flow. So thank you for laying it all out so clearly for us today. We have some questions popping up in the Q&A tab. Venkat asks, how would you integrate with external data sources to bring in external data for risk assessment during the underwriting stage of the loan approval process?
That's a great question. Like I said, the goal is to really maximize the possibilities and the inputs that we can get. And so bringing in any external data that you have is absolutely critical and really valuable. If that external data is already crowdsourced labels, you can bring those in. If it's an existing model, you can bring those in. If it's a dictionary that informs part of your model, you can bring that in. And of course, anything that helps with risk assessment, you can bring that in all into the Snorkel Flow platform today.
Makes sense. Thank you. And then another question we have is, how does Snorkel Flow incorporate techniques like active learning?
Yeah, that's a fabulous question. As you saw, active learning is all about incorporating humans in the loop. We want to make sure that our subject matter experts feel empowered to help in any part of the journey. And they are empowered and enabled to look at any slices or portions of the data and provide as much input as possible, whether it's through labeling functions, if they feel comfortable with identifying those patterns directly, or through labels, or even if they don't have that, through comments that provide kind of context behind the data point.
Amazing, thank you. Yeah, various ways to inject, subject matter expertise in the Snorkel Flow platform. You touched on sort of, the loan approval process in some use cases. What are some use cases, other use cases that I guess this could be applicable to? I know there's like a wide variety, but if you could touch on just some others so people have an idea.
Of course, we've seen a lot of examples throughout the day today. We've learned all about clinical trials and how, large documents that it's hard to process all the way through can target your analysis on places where the word drug appears, for example, if it's getting confused between drug abuse or what was the other one? I remember rubbing alcohol, which is not the right example, but alcohol abuse and rubbing alcohol. There we go. So you can kind of focus in on just the alcohol use cases, right? And so you can really target the work that your machine learning model and your analysis and your domain experts are focusing on. Other examples are the wonderful work done by Orange that Iman shared with us today about how network analysis is difficult and hard and will require a bunch of iteration for sure and must be done collaboratively with the domain experts.
Thank you so much, Roshni. We really heard from Iman and Michael, like real world examples of where this has been applied. There's a lot of others that we're not speaking to, but text classification, extraction, and all the other use cases we support, just so widely applicable. So really exciting to see this all come to life. You mentioned a bit about, like subject matter expertise and also hand labeling. People might be wondering, how much hand label data do you really need for the programmatic labeling or Snorkel approach? What would you say to that?
Of course. Snorkel Flow is based on Snorkel, the research application, in which we've proven out that you don't need any hand labels, right? That you can label your data, you can train your model, and it actually works really well out in the real world. You can have as much hand label data as you would like to have kind of that confidence that you would like about your model performance, but again, it's not required. In practice, we do recommend a little bit, again, just to have that confidence in the model, and then to target any specific kind of long tail, difficult to label, or like if a human can't figure it out easily, of course, a machine learned model is going to struggle as well. So I'm just kind of focusing in on those examples.
Makes sense. And lastly, you also mentioned a bit about, data drift and domain shift, which a lot of our speakers had talked about earlier in the day. Could you talk a little bit about how that ties into Snorkel, or things that we might be working on?
Of course. Data drift is a thing that really happens to real people in real life, and we need to really be prepared to help folks through it. And so, if you deploy your application through Snorkel Flow, then you can monitor your production models. I can grab slices of data that you care most specifically about. So the example I presented was we care a lot about what's going on with pharmaceutical companies, for example. And so you can kind of focus, like there's so much production data, you really need to find places to focus if you want to. You can kind of narrow down. If not, you can do a random sample, of course. And again, being in the same platform and iterating and getting used to this kind of iterative loop will now enable you to collaborate even on the production data, right? In
Mhm.
Snorkel Flow, if it's test data or production data, it's going to look the same. You're going to be able to kind of flip through your data and really dig into it and understand how it works.
Amazing. With that, thank you so much, Roshni, for again laying it out all for us, tying it to previous sessions, and teaching us a lot more about Snorkel Flow. Thanks
Of
a lot.
course. Thanks for having me.